I'm Magdalena and I'm going to present my study on tool modification in New Caledonian crows. New Caledonian crows are natural tool users. In the wild, they manufacture rather complex tools such as hooks and multi-step tools. A wild crow female, Betty, was able to bend and unbend flexible materials to solve extractive tasks in the lab. Her performance was cited as a unique example of Fuchs physics and reasoning by analogy in an animal. However, recent work on wild New Caledonian crows showed that in the process of making their natural hooks, crows will sometimes bend their shafts, probably to place the hooked end in a more visible position. Understandably, this finding forces us to reassess the Betty studies, since the conclusions were based on the assumption that wild crows do not bend tools. It is possible that Betty had applied pre-learned routines. We had already collected our data when this came to light, but we hope that our studies will further our understanding of Betty's performance, and also that of that species in general, even if we might not be able to tease apart pre-learned routines in the wild from causal inferences. Here we have 4 tasks, 1 bending task and 3 unbending tasks, and more subjects divided in the different groups. We will start with our first experiment, which was the bending task. The apparatus was a carved tree trunk. The tool was 2 pipe cleaners on each side of a bamboo. There were 3 rewards to be extracted. The 5 subjects were wild caught, and 4 were trained in a tool choice task, like Betty. During training, the tools were rigid. The 5th bird was tested naively, then trained and tested again. 1 subject failed training and was not tested, and all others were tested. During testing, the tools were identical but pliant. From our tested subjects, 3 were consistently successful in bending hooks. 2 subjects used the push technique, where the end of the tool was pushed against the bottom of the apparatus. It appeared likely this technique could arise from progressive reinforcement of accidental modifications during probing. Indeed, the pattern of successes and failures for Mango shows this and demonstrates trial and error learning. However, this pattern was different for Barney, as he was always able to modify his tool, and the gap in successes was due to motivation issues. But with him, we couldn't tease apart pre-learned routines from causal inferences, since he was caught in the wild. Our 3rd successful subject was tested twice. When naive, he tried to retrieve the reward with the straight tool, but failed. On his first trial, after training, he succeeded, indicated that he likely gained important information from the training, and that simply manipulating pliant material was not enough to trigger a bending action. He used the peak technique, which seemed unlikely to arise accidentally, and was quite similar to Betty's. And like her, he made no mistakes indicating trial and error learning. Then how did he proceed? Recent research on this species show they can hold a mental template of a shape they experience and then reproduce it later. Such a mechanism could be involved in the propagation of certain tools in the wild, where an individual could use a tool discarded by another, then reproduce it. The authors argue that Betty could have done this in order to make hooks, and it is possible that Agaios also used this mechanism here. Here we wanted to investigate whether our subjects could decrease the curvature of hooked tools in order to solve a problem. In our first unbending task, everything was identical except for the apparatus, where a straight tool was needed. 1 subject was hand raised, the others were wild caught. Of course, the tools provided during testing were hooked and needed to be unbent. 1 subject failed training and was not tested. From 4 tested subjects, 1 succeeded, the hand raised one. In order to solve this task, she simply financed the hooked tool inside the apparatus, then forced it down the groove. This modification technique, of course, isn't necessarily goal-oriented, and our other behaviors, for example, removing an already straight tool and trying again with a bent one, showed that she probably did not consider the tool shape in her process. It's likely here that the structure of the apparatus itself made it too difficult. Once the tool was inserted, nothing of the internal structures and how it interacted with the tool was visible to her. We tried to fix that in the next task. In the second task, the tube apparatus was essentially identical to the one used with Betty. To make accidental modification less likely, the tool required 2 unbending actions to make it long enough to get the reward out. Here we tested 10 subjects, including 2 hand-raised crows. If they failed to modify a tool within the first 5 trials, they were given experience of the physical properties of the materials outside of the task context. 4 subjects solved at least 1 trial. 2 did so consistently, but only 1, who solved inconsistently, did so after training. Here is typically how they would modify their tool. They would force the tool inside the tube, which would straighten one angle. Then they would most of the time probe with this half-modified but too short tool. Then they would flip the tool, a common behavior in this species, and straighten the second angle. Here, it was quite obvious that this technique could arise from the subject pushing the tool towards the reward. The two consistent subjects even failed at times to finish modifying the tool completely. It also appeared they did not learn across trials that the second unbending action was important, since the time they spent using the half-modified tool did not decrease. It is possible that since they could touch the reward with the half-modified tool, that it made it difficult to disregard that rewarding stimulus and finish the modification. Overall, the behavior was indicative of trial-and-error learning, and we needed more information. So we gave 8 subjects, including 3 successful with the tube, a tougher task. The tool was the same, the apparatus was much wider, so forcing the tool towards the reward in the back would result in failure. Only 2 subjects solved the task at least once. Jungle had succeeded only once, and probably did so by chance after playing around with the tool in the aviary. The other one, Crusoe, had succeeded in the tube task, and with this box task still repeatedly. He started by using the side of the box to modify the tool. It was a grueling process, and it showed that he likely intended to modify the tool, not simply force it towards the reward, though it was likely that he had generalized this technique from the tube apparatus. Though later, he switched up this technique. He turned away from the apparatus and used a gap to straighten his tool, which of course meant he didn't obey a simple rule of shoving the tool towards the reward or against the apparatus. Even more interestingly, he no longer had the stimulus of seeing the reward while he modified his tool. Here, New Caledonian crows were able to both bend and unbend pliant tools consistently in a problem-solving context, showing that this ability was not limited to Betty. The main mechanism, trial-and-error learning, was likely facilitated by the behavioral predispositions of this species, where even hand-raised and untutored juveniles will readily probe gaps with tools. This would also explain the similarities between the modification techniques shown by our subjects. The beak technique was also similar to those shown by Betty and other crows in the wild, though here our subject did not apply this technique without experience with the shape. In addition, there was a crucial difference between Betty and Agaios's techniques and the one in the wild. The bending here was applied to making the actual hooked end, which is the functional part of the tool, and quite different from an ergonomic adjustment to an already hooked tool. Our subjects could also decrease the curvature of their tools, where applying bending techniques would have been counterproductive. Thank you for listening.